Hello programmers, greetings from your last minute professor. In this video, let us learn to code binary search using recursion in Python. How does a binary search work? Binary search is used to check the existence of a particular value in a group of sorted values. Suppose you have a group of sorted values, namely 11, 22, 33, 44, 55, 66, and 77. Here, we have the input values arranged in ascending order. The secret that the binary search uses is that since the elements are arranged in ascending order, considering any particular value, the elements to the left are less than the value, whereas the elements to the right are greater than the value. For example, the elements to the left of 44 are less than 44, whereas the elements to the right of 44 are greater than 44. Assume that our search element is 55. Look at the entire list of values. The index begins at 0 and ends at total number of elements minus 1. So here, in the example considered, we have 7 elements and the last index is 7 minus 1, that is 6. That is, starting index is 0 and ending index is 6. Now, middle index is nothing but starting index plus ending index by 2. Note that the division used here is floor division. Suppose 8 elements are there. Then the middle index would be 0 plus 7 by 2. So normally if you perform the division, you will obtain the answer as 3.5. But index cannot be 3.5. It can either be 3 or 4. That's the reason we go for floor division. That is, we just consider the quotient when we are calculating the middle index. Now in our case, middle index is 0 plus the ending index is 6. So 0 plus 6 floor division 2, that is 3. The element at the middle index is 44. The first search made here is whether the middle element is the search value. No, 44 is not the search value. So we have two options. We need to search either to the left of 44 or to the right of 44. The next search is comparing the middle element with the search value. So 55 is greater than 44. If at all the search element 55 is present, it should be to the right of 44. So we restrict our search interval with the elements to the right of 44. So that can be made by updating our starting index to middle index plus 1. So starting index is 4 now. We do not make any changes to the ending index. It is still 6. Now let us recalculate middle index and repeat the search procedure. So middle index is 5. Again, is the middle element our search value? No, 66 is not our search value. Now, let us compare the middle element with the search value. 55 is less than 66. So if at all 55 is present, it should be before 66. So let us update our ending index as middle index minus 1 to restrict our search interval to the left of 66. So ending index becomes 4. We do not make any changes to our starting index. It is still 4. Now let us recalculate middle index. It is 4. Again, repeat the search. Is the middle element our search element? Yes. So you can return the index. This is how a binary search works when the element is present. But what if we search for an element not found? Or in other words, if an element is present, how long should we continue this process of checking? That is, we find the middle element, compare it with the search value, and take necessary steps. That is, we restrict our search either to the left of that or to the right of that. The condition is that when starting index is less than or equal to ending index. So let me give a short description of what we saw till now. In general, this is how the binary search works. First, initialize starting index as 0 and ending index as n minus 1. That is, the total number of elements in the list minus 1. Find middle index using starting index plus ending index flow division 2. Middle element is the element present at the middle index. There can be 3 possibilities when we compare middle element and the search value. The middle element can be equal to the search value, or the middle element can be less than the search value, or the middle element can be greater than search value. If the middle element is the search value, we can print the index and stop the searching process. If middle element is less than search, then we need to search to the right of the middle element. If the middle element is greater than search, we need to search to the left of the middle element. So what does it mean to search to the right of the middle element when it is less than the search value? It means we restrict our search interval in this pattern by assigning the starting index as middle index plus 1 and retaining the same ending index. Then we recalculate the middle index. When we say we search to the left of the middle element when the middle element is greater than the search value, it means I'm retaining the starting index and assigning ending index as middle index minus 1. Then I recalculate middle index for this range. Now let us code this in Python. So first let us get the list of input values from user. So I'm keeping it in a list named numbers. Then I'm getting the search value from user, and I have a function called binary search. In the bracket, you can see there are 4 values. So what are the 4 values that we are seeing? What are the 4 arguments? The first thing is numbers. So numbers is the list, user given list. Next is the search, that is the value to be searched. Then I'm having 2 arguments. Let me explain it. Here, this is a function definition. The first is the list, second is the search value, and the next is the starting index, and the next argument is the ending index. So when I initialized, the starting index would be 0 and the ending index will be number of elements minus 1. That's the reason I have mentioned 0 and length of the list minus 1 when I'm making the function call. Now let us see what comes inside the function definition. So as we saw, our search process as a condition, that is starting index should be less than or equal to ending index. The formula for the middle index is equal to starting index plus ending index flow division 2. Now we have 3 possible cases. That is, the middle element is equal to the search element. If that is the case, I need to print the index and I can stop the process. That is, I can get back to the point where the function was called. So I'm giving it as return. The other possibility is that the middle element is less than the search element. In that case, I need to assign accordingly. So this is the list, this is the search element, and I am assigning the starting index as middle index plus 1, and the ending index remains the same. That is searching to the right. The other possibility, that is under the else part, what would be means the middle element is greater than the search element. In that case, when I am again calling the same function, that is recursion is a function calling itself. So here when I'm calling the same function, how I'm assigning is that the starting index remains the same, whereas the ending index is middle index minus 1, searching to the left. Now, this is how the searching process goes. In case this is not true, that is, the starting index is greater than ending index. In that scenario, that is the else part I'm giving here, what should I do? That means I have searched the elements using binary search, but the element is not found. So in that case, I can print element is not found. So let me save the code and run it. When I'm giving the input, I'm giving it as comma separated values as I have coded accordingly using list comprehension. Suppose I'm searching for an element that is in the list. I get the output like this. What happens when I'm searching for an element that is not in the list? I'm giving the same list and searching for 56, which is not in the list. My output is element not found. That's it. To encourage and support the work, do like, share, and subscribe. Thank you for watching.